So in reading this question, the first thing that should really stand out to you is that it's a square bracket -1 to 0. And that means that we have a closed interval that we are trying to find extrema on. Now, you also will notice that this function f of x is a polynomial. And because it's a polynomial, it is also continuous as a function. So we have a continuous function on a closed interval. But really the important thing to notice is this closed interval, because as we discussed in class, our process is not to draw a number line, but to compare the function values at two important places, the critical numbers, and then also at the endpoints. So what we will first do is find these critical numbers. And do remember that for the critical numbers, we have to first find the derivative. So we take our function and we differentiate. We would get 9x squared minus 6x minus 3, and the plus 7 goes to 0. So finding our critical numbers, we set our derivative equal to 0. Now, in this particular case, we look at the equation we have. We notice that the highest power is 2. So that means we have a quadratic equation. We have all of our different quadratic methods. We can factor. We can use the quadratic formula. Usually factoring is going to be the easiest thing to try. Now, when we factor, the first thing that we ask is there a GCF? And you'll notice 9, 6, and 3, they all have 3 in common. So we will take out that 3. Now remember that when you take out the 3, you are going to get the leftover polynomial by dividing each of these terms by 3. So that will leave us with 3x squared minus 2x minus 1 is equal to 0. Now we still have to keep trying to factor, and so we'll try to factor these 3 terms. So to do that, we'll think about two numbers that multiply together, 3 times -1, -3, and they have to sum to give us -2. So thinking about this, the only two options really are 3 and 1. To get the -2, we'll need to have a -3 and a +1. So -3 times +1 works here, and it will also work with the -2. So this is our winning combination, -3 plus 1. So once we have that winning combination, we take our 3x squared minus 2x minus 1 and split up this middle term. So we split it into -3x plus x minus 1, and then our 3x squared. Now we still have our 3, our GCF, that comes straight down. After you go through the grouping method, you will bring out again first the x, or the 3x, and then you'll be left with x minus 1, bring out a plus 1, and what you will see your final factorization after you go through grouping here with your 4 terms will be that you have 3 times 3x plus 1 times x minus 1. And we want to set that equal to 0. So once we set each of these factors equal to 0, we will have 3 is equal to 0, which gives us no new information. The 3x plus 1 factor, when we set that equal to 0 and solve, we get x is equal to -1/3. And then the x minus 1 factor, when we set that equal to 0, we get x is equal to 1. Now, we need to talk a little bit about how you deal with these critical numbers. If you look back at the very beginning of the problem had this closed interval, -1 to 0. So when we get these critical numbers of -1/3 and 1, if we're only looking at a closed interval, and again our closed interval is -1 to 0, if you think about -1/3, that's in this interval. So that's perfectly acceptable to think about that for a critical number. But this x is equal to 1 is way over here outside of that interval of interest. So yes, x is equal to 1 is a critical number, but it's outside of the interval, and so we are not going to consider it when we plug into the original function. So the only critical number of interest, so I'll call it the critical number of interest, is equal to -1/3. So now you go to step 2. So step 2 is going to be that we plug in our critical numbers and our endpoints. And we plug into the function because we're trying to find the y values corresponding to the critical number and endpoint to compare. So our function was f of x is equal to 3x cubed minus 3x squared minus 3x plus 7. We plug in -1 into our function and compute, and we get 4. Doing the same for the 0 endpoint, we will get 7, and plugging in for f into -1/3, we will get approximately 7.5. So at this point, what we do is we compare these three numbers, so our y values, and we see that the highest y value is the 7.5, so that is our max, and our smallest y value is 4, so that would be our minimum on that interval. Now, to write up our answer, it is important to understand that we will write down the absolute max is the y value of 7.5, and that happens at a corresponding x value of x is equal to -1/3. The absolute min is for the y value, and that happens at the x value of -1. So anytime you have an x value, that is always going to be right after the word at.